This video is on the objective calculate a confidence interval for a population mean with the population standard deviation unknown, right? Sigma is unknown, but with a calculator. All right, this is taking you through how to find that lower value and upper value. Remember the sample mean minus the margin of error, the sample mean plus the margin of error, but with a calculator, having the calculator just kind of spit those values out for you pretty easily. Alright, so this is the first video on this, number one. Probably do a second one as well for a question related to this objective from your Newton Alta homework. Alright, so here's the question. Now again, if you're unfamiliar with the topic, please hopefully you've read or go back and read section 8.2 from your Newton Alta from your OpenStax statistics book, or click on more instruction and see how to enter the information. This is a calculator objective, so if you click on more instruction, they're going to show you how to use the calculator to solve these problems. All right, so first I'm going to go through and show you, remind you, how we can use, how we can figure out the confidence interval by hand, right? Like the long way. And then I'll show you the short way, of course. I'll show you what they want you to see, how to use the calculator. All right, so suppose that the wait times for patients in an emergency room, so wait times, are normally distributed with an unknown mean, right? Mu is unknown, and also unknown standard deviation. So sigma is unknown, right? Meaning you're going to use t-scores instead of z-scores. Right? Remember, when sigma was known, you used z-scores, right? Standard normal. When sigma's unknown, you're using these t-scores, right? The student's t-scores. All right, so a random sample of size 18, right? 18 patients is taken and gives a sample mean of 25 minutes, right? So these 18 patients averaged a wait time of 25 minutes in the emergency room, and a sample standard deviation, that's S, right, of 2 minutes. So it says use a calculator to find a 95% confidence interval estimate for the population mean using a student's t distribution, and round your answers to 2 decimal places, final answers. Okay, so I'm going to go to a piece of paper and refresh your memory. Hopefully you've seen this in an objective before without the calculator. So remember, when I'm trying to find a confidence interval, I'll use CI for confidence interval. I'm trying to find a confidence interval for the mean when the population standard deviation is unknown. Remember the margin of error, right? The margin of error was some t-score with an area of alpha over 2 above it, multiplied by the standard deviation for the sample means, which was estimated by, because you don't know sigma. Normally it was sigma over the square root of n, but you don't know sigma, so you estimate it with S, right, the sample standard deviation. And then the confidence interval was just, the lower value was our sample mean minus the margin of error. The upper value of the confidence interval was the sample mean plus this margin of error. All right. And then this t distribution that we're looking at, to find this t-score had n minus 1 degrees of freedom, right? df for degrees of freedom. Remember, every single different student's t distribution depended upon the sample size, right? The different sample sizes gave you different t distributions, but they're still like normal, right? The t distribution was very similar to a normal distribution in that it is symmetrical and bell-shaped. All right, so for this particular example, let me actually do it by hand first, and then I'll show you the faster way with the calculator. So the sample size that we were given here was 18 patients. So that means we're looking at a t distribution with 17 degrees of freedom. Remember, it was n minus 1 degrees of freedom. And the sample mean, right, for these 18 patients was, a 25-minute average wait time, and the sample standard deviation S was 2 minutes. All right, so I'm going to use all this information here. Now, they're asking us to create a 95% confidence interval. 95% confidence. So I have a 95% confidence level. And if you're looking at 95% confidence, that means that this alpha, remember alpha was the significance level, this is what's left over. All right, 95% is in between the two values, the lower and upper value of our confidence interval, meaning that there's 5% left over, or 0.05, and then if there's 5% left over, that means there's 2.5% above the upper value and 2.5% below the lower value. So that's that alpha over 2 that's mentioned up here is 2.5%, or as a decimal, 0.025. All right, so I'm looking for, what's the t-score with 17 degrees of freedom. What t-score for the t-distribution with 17 degrees of freedom has 2.5% above it? All right, now this is, because I'm not given a chart here, we can use that inverse t. All right, so calculator's up. I go second, distributions, go down to that number 4 there, the inverse t when I'm trying to find a t-score. The first value you enter is an area to the left. All right, it's an area to the left. So if I want the t-score with 2.5% to the right, 2.5% above it, the value I'm going to enter on the calculator for the inverse t is 97.5%. Right? If you have 2.5% above, it means you have 97.5% below to the left. So 0.975 is what I'll enter here. And then degrees of freedom was 17. Right? 18 minus 1. And this is how you'd have to enter it on an older one, where you have the area to the left and then a comma and then the degrees of freedom. All right, so remember on the charts it was like the 3 decimal places. I'm just going to leave it this way. This is so the t-score I need is 2.1098, right? 1098 something. What I'm going to do is I'm going to take that and find the margin of error. I'm going to multiply that t-score by s over the square root of n. So I take the previous answer, multiply by s, which our sample standard deviation here is 2, divided by the square root of the sample size, square root of 18. There's the margin of error, right? So the margin of error for this particular problem is 0.99457, 99458, whatever, approximately that. Again, I'm just going to store this as x, store as x, and now every time I use the letter x, it's the margin of error. And then we can get our confidence interval, right? I take my sample mean, I take 25 minus the margin of error, 25 minus x, and to 2 decimal places, that's approximately 24.01 for the low value when I take the 25 minus the margin of error. And then 25 plus the margin of error, 25 plus x, you get 25.995, 25.994 or 25.99 would that if I rounded to 2 decimal places. So I'd be 95% confident that the average wait time for all patients, right, the entire population, is somewhere between 24.01 minutes and 25.99 minutes. Now that was the long way. What I just did there was the long way. The much faster way to find a confidence interval for a mean on your calculator is to go to hit the stat button, right? Hit stat, go over to tests. Now hopefully you remember this from section 8.1. Remember z interval? Remember z interval? That was when you wanted a confidence interval for a mu, when you wanted a confidence interval for a mean, but you knew sigma, right? Because remember, when you know sigma, you're using z-scores, so thus the z interval. Right below that, number 8, see t interval? Going to use that. Going to use t interval on the calculator. Go to hit the stat button, go over to tests, down to number 8. Because remember, when you don't know sigma, you're using t-scores, right? This t alpha over 2. So that's why it's t-interval. So this t-interval is what's used when you're trying to find a confidence interval for a mean, but you don't know sigma. Sigma's unknown. So I go t-interval. Now, looking back at the problem, do I have a list of data? No. They didn't give me these 18 patients' wait times, right? They didn't give me a list of data. What they just gave me were some statistics. They gave me the sample mean, the sample standard deviation. So I don't have a list of data. All right, so I'm not gonna highlight this. You see how it has data, and then it says, oh, what's your list of data? And is there a frequency list or a probability list? We'll get to that in a later objective. We were given statistics, right? So I go over to stats. Hit enter on stats here, and then just enter the appropriate information, right? What was the sample mean? What was X bar? Well, that was 25. What was S sub X? What was the standard deviation of the sample? S, right? What was the S? It was 2. N, what was the sample size? Right? So they can determine the degrees of freedom for the t distribution. There was 18. And then what was the confidence level? 95%. Now don't enter as a percentage. You got to enter as a decimal. So you see how it's 0.95 already? So I don't need to change that. It's already 95%. But if it was like 99%, you put 0.99. If it was 80%, you put 0.8. You got to enter your confidence level as a decimal. I'm going to calculate, and look at this. 24.005, which to 2 decimal places would round to 24.01 like I had here. This is an issue. Now, if they're saying use the calculator and use the calculator output, if I rounded this to 2 decimal places, it would be 26.0 because it has 0.995. All right, so if I'm again, remember when I had my output earlier, it was 25.994 something. So that I rounded that to 25.99. But here, if I'm using strictly this calculator output, I would round this to 25.99, and bump it up to 26.00. All right, so this gets bumped up to 20, based on the calculator output. All right. Okay, so back in my, but again, 25.99, 26.00, practically the same thing. So based on that calculator output, rounding to 2 decimal places, the lower value, so we're 95% confident. We're 95% confident that the average wait time for all patients, that the true population mean, is between 24.01 minutes and again, using just that calculator output, rounding to 26.00 minutes. Right? Let's see if that worked out. Wonderful. Again, please, see how they use that t-interval function here. Again, that's because sigma is unknown. T-scores, t-interval. And they go through that whole thing. Great. And that's it. Very quick and easy. Use t-interval. And again, the second video I put up on this, I'm just going to go straight to using that t-interval. Wonderful. All right. Hopefully this video helps, and when you do these problems for this objective on your own. And thanks for watching.